but I'll be on it always, always and ever.
Hi guys, welcome back to the Pink Chemist. So in today's video, we will be going over an example for excess reactant or reagent. All right. Now, if you haven't looked at our previous video, which is limiting reagent, you need to start at that video first and then come back to this video. All right. Now, so we're going to go ahead and hop right on into it. Now, we know that our first step is to balance the equation, but when we look at our equation, the equation is already balanced. Now, that will not always be the case, so make sure that you're paying attention because a balanced equation is essential to making sure that you have the right answer, okay? Next, we're going to list out our given and our want. Now, when I read the problem states, what is the theoretical yield of chlorine gas if 4 grams of FeCO3 reacts with 4 grams of O2? I can see that I am given two givens, one being 4 grams of FeCO3 and then the other being 4 grams of O2. Now, when I read the problem again, it tells me it asks me what is the theoretical yield of chlorine gas. That lets me know that that is what I'm trying to find, okay? So I know that my one is going to be grams of chlorine gas, which is CO2, okay? Now, because I'm given two givens, I know I am going to have to do one set first of railroad tracks, and then I'll do my second railroad track in a little bit. So let's go ahead and create some space. Now, make sure that you leave some space because when it comes to excess reactant, you're going to have 3 sets of railroad tracks, okay? Now, I'm going to identify my first given, which is 4 grams of FeCO3, and then my one is grams of CO2. So at this point, I am pretty confident, or should be, with setting up my grams to grams railroad track. You should know at this point how to set up your grams to gram railroad track. If you are struggling with that, you need to go back to the video of gram to grams. Okay? Because by the time you get to excess reagent, you should already know how to set up your railroad tracks. Okay? Now, I know that when I have mole over gram, my mole is always 1. And when I see that I have the unit grams, I have to find the molar mass. So I got to separate Fe and Cl. I have 1 Fe and 3 Cls. My atomic mass for Fe is 56 and my atomic mass for Cl is 35. Okay, so I got 56 and then I have 105. And now I got to do the math because I have to add that up. 105 plus 56 is going to give me 161. So 161 is my molar mass for FeCO3. Now, when I have mole over mole, I got to look at my coefficients. So my coefficients for CO2 is 6 and my coefficient for FeCO3 is 4. When I have grams over mole, my mole is always 1 and my grams let me know that I have to find a molar mass. I see that I have 2 chlorines, so 2 times 35. I believe that's what, 70? Let's check. 2 times 35. Yep, that's 70. Okay. So now that we have that out, now we're going to multiply our numerator. So 4 times 1 times 6 times 70. That gives me 1,680. That's my numerator value. Then I'm going to multiply my denominator, which is 161 times 4 times 1, which gives me 644. When I divide 1,680 by 644, I get, I'll try to create some space. I get 2.61 grams of CO2. Okay, 2.61 grams of CO2. Now let me go ahead and set up my TY, my limiting, and my excess reactant, and the excess amount. Okay, I have all of that set up over here. Okay, so now I'm going to create room for my second railroad track. So on my second railroad track, I'm going to put my second given, which is 4 grams of O2. Then my wanted is going to be the same, which is grams of CO2. So let me go ahead and fill out my railroad track. Okay. Again, should be something that we are confident with doing because we have already done this so far. Okay, so my mole will be 1. I see that I have 2 oxygens. So 2 times 16 is 32. So that's my molar mass. My mole for CO2 is 6 and my mole of O2 is 3 because those are the coefficients. And then my grams for CO2, I don't have to redo the math for that because I already did it in the first railroad track. And then my mole is 1. Now, when it comes to the value, when I'm multiplying my numerator, because my numbers are still the same as my first set of railroad tracks, my value will still be 1,680. The only difference now will be my denominator. I have a different denominator. So 32 times 3 is 96. Okay. Now I got 96. Now I'm going to divide that. And my value that I get here is 17.5 grams of CO2 because that is what I want. Okay. That is what I want. Now, here is where limiting reactant, that video that we did before excess reactant, helps you to identify because you want to identify your theoretical yield and your limiting reactant first before you set up your third railroad track. Okay. So you are able to see that your theoretical yield out of the 2 values that we got, your theoretical yield is going to be your smallest number. And in this case, our smallest out of the 2 is 2.61 grams of CO2. Okay. Then our limiting reactant, the reactant that we use to help us get to that smallest value is FeCO3. You can see that right here. That's literally your given that help you to get to that smallest number, which is this one. Okay. Now, since FeCO3 is your limiting reactant, okay, your excess reactant is going to be the reactant that you started with that help you to get to the larger value. Okay. So in this case, it is O2. So for us, it is O2. Now that we have our excess reactant, we now want to find the excess amount. Okay. How much excess is remaining? All right. So in order to do that, now we have to set up a third railroad track. So I'm going to do the third railroad track down here. Your third railroad track, your given, is going to be your theoretical yield, your TY. Your wanted is going to be your excess reactant in grams. Because remember, we're going from grams to grams. So we see that our theoretical yield was 2.61 grams of CO2. We already have that written down. Then our wanted in grams is going to be the ER, which is O2, our excess reactant. So now that we have our given and our wanted set up, we are going to do the same thing that we've been doing since grams to grams and setting up our railroad tracks. Okay. So again, this is something by the time you get to this third railroad track, you should be doing this as a breeze. Okay. So my mole over gram, my mole is 1. At this point, I don't have to do any molar mass because the molar masses that I would need to fill in my third chart is what I've already found in my two charts above. So my gram of CO2 is 70. I already did it. I don't have to redo it. My mole of O2 is 3 and my mole of CO2 is 6. Those are the coefficient. Then my gram of O2 is 32. And then my mole of O2 is 1 here because anytime I got grams over moles, my mole is 1. Now I'm going to do the math. I'm now going to multiply my numerator. In my numerator, I got 2.61 times 1 times 3 times 32, and I get 250.56. Then in my denominator, I get 70 times 6, which is 420. And when I divide 250.56 divided by 420, I get 0.59, but I'm going to go ahead and round this to 0.60 grams of O2. Okay, so this is your excess amount. This is your excess used. This is how much you use. This is how much excess was used. 0.60 grams of O2. Now to find the excess amount, like the excess remaining, this is a part where you really have to pay attention because this is the very last step. So you want to go to the original amount that you started with. We know that our excess reactant was O2. So being that it was O2, we want to go to the original amount that we started with. We started with 4 grams of O2. Okay? We started with 4 grams of O2. We want to subtract that amount from the amount that was actually used. The amount that was actually used was only 0.60 grams of O2. We only use 0.60 grams of O2. So to find out the excess remaining, we're going to subtract these two. So 4 minus 0.60, it gives us 3.4 grams of O2. And that is your excess remaining amount, 3.4 grams of O2. And that is how you do excess reactant. I know that it is a lot of work, okay? But I think that the amount of work that we have to put in to get to all of our answers completed, because it's so repetitive, it should help you to be better at doing grams to grams stoichiometry. So I hope this helps. See you in the next video.
Don't play with it, don't be dishonest. Ay, still not understand.